So good morning, everyone. Once again, my name is Juho. I'm working for Samsung Electronics and have been working on this mobile communication during the last 24 years. I'm very pleased to share our vision for 6G today. And I remember we had also a keynote speech from other person last year here. Then we talked about 6G vision at that time as well. So I would like to recap what we are thinking about 6G. Then I will try to introduce recent research results on AI for communications. So that's the motivation for having this title, 6G Future Wireless for the AI Era. So I will start with a general view on 6G and recap some key technologies, then move on to AI for communications. So I'm sure everyone here is very much expert on the mobile communication. So we all know that every cellular generation has enhanced user experience and also opened up new services. And the trend was like for each generation, industry has tried to improve peak data rate and also improve the capacity of the overall system. It has been like that until 5G, and so far everything was good. Now then, we need to review the current situation. Then hearing from our end users, there are some different responses. We have been telling this story over I think more than 1 year. So in case of US, somehow people are very happy. For example, they didn't have, how can I say, okay, 4G LTE network was also good, but it seems that they are appreciating very big improvement of the data rate with the 5G. But however, in case of Korea, and also some other countries, people have been very happy with the 4G LTE Advanced. Then they are feeling that there's not much difference with the 5G. Of course, 5G has been contributing a lot for the whole society. And if we see the data traffic amount, the data traffic amount has been increasing continuously. So without 5G, it would not have been possible for people to enjoy their applications and services on their mobile phones. But nevertheless, in terms of the giving good impression about new type of services, it is also true that industry is still kind of trying to find new services. There has not been so much difference in terms of new service applications compared to previous generation. So that is the observation on the customer feedback. Then in terms of technology trend, we see big trend which can be characterized as softwareization, virtualization, and the native support of AI. In today's communications network, most implementations are based on hardware, customized hardware. So once we deploy networks, it is very hard to replace the existing hardware equipment. Then going forward in the future, we expect the software-based implementation will be really big trend. Everyone is working on it, and also the implementation will be realized in the cloud environment, and we expect the native support of AI functionalities will become quite important. So having these customer experiences and the technical trend, what we are thinking is that the continuous further enhancement of mobile broadband is #1 importance. Of course, industry has been trying to expand to vertical sectors in 5G. But in terms of the having really big kind of momentum for new generation, we think the mobile broadband is quite important, #1 importance. And at the same time, we also need to utilize AI innovations. So basically, combining mobile broadband enhancement with AI innovations will be quite crucial for 6G. And then in terms of use cases, many people have been talking about XR, like immersive communications for 5G, and such effort will continue towards 6G. Then we hope we can have new device types which can be used in daily life, for example, AR glasses. And digital twin to connect the physical world to cyber worlds, to connect cyber world to physical world. That seems to be providing new opportunities in the future. Then massive communications to connect everything to human will still be quite important. And the ubiquitous connectivity, good example is satellite communication, so connecting the phones to satellite. That seems to be a big trend. And also fixed wireless access, which is most kind of representative use case for 5G. So all these emerging use cases have to be well supported in 6G. So then how can you realize such a vision and use cases? As I said before, the native support of AI seems to be quite crucial. That will be the one that can clearly differentiate 6G from the previous generations. And the sustainability is now becoming the #1 priority for the whole world. When I started my work around 2000, and when it discussed about 4G LTE design, there was also a proposal to consider network energy consumption. That time, that was not so serious. In my case, I was making a joke, like it's better to turn off lamps at home instead of discussing about network energy consumption. But now, with this very drastic increase of traffic and also the use of communication networks in all the fields, the energy consumption of the communication network seems to be quite important. So we have to really try to reduce energy consumption and also other aspects for sustainable society. Then the coverage. If we don't provide good coverage, then of course the cost for installing networks will be quite high, and they will not be good to motivate operators to invest to deploy new 6G networks. So we think providing good coverage is quite important, and also from end user perspectives, being connected every time, especially when they are in a dangerous situation, when there are some accidents, providing connectivity to them every time, all the time, seems to be quite important. So ubiquitous coverage is also quite important aspect. Then security and the resilient operation of network is something that we have taken care more compared to the previous generation. So then let me move on to some technology aspect. Before talking about the technology aspect, we need to consider what spectrum we are expecting for 6G. Spectrum is #1 asset for mobile communications. Looking at the current situation, the upper 6 GHz from 6.4 to 7.1 GHz is being considered by some regions. It could be used for 5G bands, it could be used for 6G. Then for the 7 to 8 GHz band and the 12 GHz and 13 GHz band and 15 GHz band, those bands are to be further discussed. So we identified these 3 bands as a good candidate for 6G new spectrum, and we expect with 6G maximum kind of 400 megahertz can be available for an operator. Of course, depending on exact allocation of frequency band, the bandwidth for each operator can be different, but we expect the trend of increasing bandwidth will continue to 6G. So compared to 100 megahertz bandwidth in 5G, we expect up to 400 megahertz bandwidth can be available for 6G. So having this variety of spectrum bands that could be available, then we can think about different technologies. So in terms of sustainable network, how to reduce network energy consumption. So far, the basic concept for mobile communications has been that all the components are included in a kind of carrier in network operation. So one component carrier, one carrier has everything. Then because of that, it is very hard to turn off certain carrier even though there's no traffic. So for 6G, we can consider more drastic approach. So for example, having coverage layer and also the capacity layer. So basically, coverage layer at low frequency band can provide basic connectivity, and the capacity layer can provide a large data traffic when there's demand. If there's no demand, we can easily turn off capacity layer, for example. So by doing so, we can drastically improve network energy consumption. Then of course, then core network has to be involved to provide a better kind of view to operators to understand how much energy consumed for providing certain services required for each user. Then in operating dynamic on-off of certain cells, of course, we need to have very good collaboration between network and devices. We don't want to sacrifice one side to save energy on the other side. In terms of the ubiquitous coverage, we are considering various technologies, and some of which were also introduced last year. So for this new band, 7 GHz and 13 GHz, in order to provide the same coverage as the currently available 3.5 GHz band or C band, we need to have quite nice beamforming operation with quite large number of antenna elements. And we believe this is very kind of popular feature in the industry. Everybody is working on it. And for now with 5G, this TDD band is used a lot compared to the previous generation where FDD bands were quite dominant. With TDD band, there's a separation between downlink and uplink. Because of that, typically uplink coverage is not as good as FDD. So as a tool to improve uplink coverage, 3PP has been working on the concept so-called SBFD. So basically allowing some portion of the TDD band for continuous uplink transmission. And we expect 6G can have further improvement of these SBFD technologies. And the non-terrestrial networks, I don't need to add more, so it will continue its evolution in 6G. Then, as the way of improving the existing low-frequency band, for example, at power on range, we are considering having distributed MIMO approach. In short, it is called DMIMO. By having this collaborative transmission from multiple sites, we can drastically improve the selective performance that you can improve coverage. And for millimeter wave, the typical implementation is relying on this analog beamforming with the many antenna elements. With analog beamforming, we can only form one beam at a time, as shown in the left-hand side figure. Because of that, the opportunities for uplink transmission for each device is limited. By putting some delay component in each RF path for each antenna, we can create a frequency-selective beamforming, frequency-selective beams. So by creating frequency-selective beams, we can schedule multiple devices simultaneously, and this results in more scheduling opportunities for each device. So by having more opportunities for uplink transmission, we can improve uplink coverage. So we are still working on all these technologies to realize them in 6G time. And the waveform. Waveform is always the fundamental aspect when you design new system. This frequency domain spectrum shaping, of course, can be done by implementation without specifying the exact receiver filter in the standard. Without specifying the filter exactly in the standard. However, this results in this kind of implementation-based approach may result in performance loss compared to the optimal design. By optimal design, I mean that the filter coefficient is standardized, so receiver can be optimized. So by having more optimized approach, then with this frequency domain spectrum shaping with spectrum extension, we expect, for example, 5 dB decrease of PAPR that can be turned into extended coverage. And particularly for this new band, which is higher than the current frequency band, we think this kind of waveform enhancement for optic coverage extension can be quite important. And the channel coding, yes, we have nice channel coding schemes in 5G, LDPC code and polar code. Even though we don't expect quite much increase of peak rate, for example, 10 times increase, we don't expect such large increase of peak rate, but still with 6G, there will be an effort to further improve peak rate, for example, data rate for 2 times. So each device will have to support larger data rate than now. Then the current LDPC design may not be optimized for supporting higher data rate. So it can result in more energy consumption at the device side, and we don't want to get complaint from our customers that 6G device is spending too much battery power. So we see there's an opportunity to consider LDPC code enhancement, especially in terms of having better trade-off between the performance and the battery power consumption and the decoder throughput. And in case of polar code, with the advancement of technologies, there is a demand for increasing the uplink control information size. Then the current polar code doesn't support very large amount of UCR payload, so we see some need for enhancing polar code to support larger block size. And the modulation. Most of the communication engineers are quite familiar with this scale constellation. It has been there for many, many decades. Of course, it can't just continue that way. However, considering that we are really trying to do our best to reduce energy consumption, then we need to look at whether such scale constellation is the best approach. If you see other industries like the broadcast standard like ATSC, they are already using the non-scale constellation, non-uniform constellation. So by having non-uniform constellation, we see the possibility of reducing required SNR, then they can contribute to reduce energy consumption. For this native AI support for communication systems, we are looking at various components of the communication systems like radio unit and digital unit and RAN intelligent controller server, RIC server. So we are assessing the demand for using AI for different components, and our goal is to improve user experience and reduce energy consumption and provide better performance by utilizing AI. And we have been doing quite much effort, and we are now getting some promising results. So the first example is applying AI for DPD operation. So in order to save PA power consumption, we can apply the envelope tracking. Then, in order to have meaningful energy consumption gain, we need to support multi-level envelope tracking. Within one wave principle, we can change the bias. We can change the PA operation point multiple times. However, that causes some issues. In order to improve linearity, we typically apply DPD in front of PA. But then with such a change of PA operation point, there's a non-linearity cost at the time point where this PA operation point changes. And the conventional approach for DPD, for example, GMP model-based approach, cannot really determine the good coefficient for DPD. So we are struggling because of that problem. Then we applied AI. Then it turned out that AI is quite good to resolve such issues in which we don't have good understanding. So this seems a very good example. So we can have a good combination of DPD and envelope tracking thanks to help from AI. And the next example is AI-based channel estimation for SRS. For this downlink scheduling, we typically get the channel information through SRS, particularly in TDD band. When the RF condition is bad, for example, the device is located very far away from the base station, then in receiving SRS, we suffer from quite a big noise level. Then it results in performance loss. So by utilizing AI for the channel estimation based on SRS, we observed that the channel estimation performance itself can be drastically improved, as you can see on the right-hand side. And that contributes to improve the system performance, particularly when the SNR value is quite low. Next example is applying AI for this channel decoding operation. For the UCI transmission on the uplink, for small size UCI transmission, there's no CRC. With no CRC, the channel decoder could contain some errors, and if those errors are forwarded to further operation at the base station digital unit, then it could cause non-negligible issues in the overall system operation. Imagine that you are transmitting HRQ feedback, it contains error. You are transmitting CQI feedback, it contains an error. Then such errors could be accumulated in the system that could cause big issues. So then we found that by applying AI, by providing multiple features, then AI could help detect such undetected error situation. With that help, we saw big improvement in overall performance. And the next example is CSI compression. Of course, there's a lot of debate on how to utilize AI for CSI compression. And this example doesn't mean that our company has the position that we want to pursue this. So this is a kind of research example. We are still evaluating what the best approach is regarding the use of AI for CS compression. This is one example that, okay, as a network vendor, Samsung is of course producing both network and device, but this time we are playing network vendor. As a network vendor, we want to get good CSI feedback utilizing AI model. Then we don't want to implement multiple decoders, multiple AI decoders, multiple AI models. We want to implement only single AI model, but at the same time, there may be different implementations of AI models for different device vendors. Then how can you ensure having universal single AI decoder at the network side? That is a big question. And we found a way of implementing that approach. So basically providing data set to device vendors. Then device vendors can implement their own AI model. Then we can still operate single AI decoder. So this seems to be quite promising, but of course it doesn't mean that it will be adopted in the standard eventually. There are multiple candidates. And the next example is more about the system level application of AI. When a user goes out from home in the morning and moves to his or her office using train or using a car, then there can be a variation in radio conditions. However, there can be some pattern observed in terms of traffic, in terms of applications, in terms of radio conditions, etc. for a certain user. Then we could have some good prediction so that we can prevent undesirable events happening to that user. For example, radio link failure or drastic decrease of the service quality, etc. So by utilizing historic data from particular user and also taking into account instantaneous radio condition. By combining these two, we observe that we can improve the user experience. So then, of course, we need to have some help from the AI. Then energy saving, application of AI for energy saving. Key question when you apply energy saving to network is that we have to guarantee KPI. Of course, if we sacrifice KPI a lot, then we can turn off, as an extreme case, we can turn off network quite a long time. But then, of course, then the KPIs could be quite much degraded. So we need to keep a good balance. So by having this AI, we can have good prediction on the traffic situation and the KPI. By doing so, we can increase opportunities for turning off as many components as possible, as many cells as possible in the network. And RAM parameter optimizations, depending on the cell's location and environment, we may need to have different parameters like beam direction, antenna direction, etc. So for those parameter optimization, we can utilize AI as opposed to human effort. So it can help decrease cost for network operation. So finally, we'd like to make comment on the overall timeline of 6G. The 6G timeline is kind of, how can I say, halfway or almost decided in 3PP, but the final day, the exact timeline for delivering the final standard for 6G is yet to be decided. So in our view, it is quite important to provide specifications by March 2029. So this is the date for AS1 freezing. So by doing so, we can provide 6G equipment early 2030, and it can help our industry continue businesses and provide new service experiences to our customers. That's it from my side, and I hope I didn't exceed too much time, my allocation time. Thank you.